This video has been sponsored by KiwiCo, but more about them later. A couple years ago, I attempted to make transparent wood, which is supposed to be almost as clear as glass, but much stronger and shatterproof. My main reason for making it, though, was mostly just because I thought it looked cool. My results were kind of okay, and I was able to make a few almost decent pieces, but I had a lot of problems with the process. It was a lot more difficult than I thought it would be, and none of my pieces were as nice as I would have liked. I also really wanted to make some larger ones, but every time I tried it, it ended up cracking after a day or so. Instead, I settled for some smaller ones, which didn't crack, and they just became really warped. It was transparent though, and at the time, I felt that it was good enough, but this was what it looked like after sitting around for several months. They were all yellow and cracked, and clearly this wasn't the best method. So, I've decided to try it again, and there was recently a paper about transparent wood that kind of went viral. I'm not going to be using their method though, and I'll mention a few reasons why throughout the video. Instead, I wanted to try something from a paper published in 2016, which was actually 2 years before my first attempt. I have no idea how I didn't find this back then, but it seemed to avoid all the problems that I ran into. To get started with it, the first thing that I needed was a piece of wood, or more specifically, a piece of balsa wood. What was nice was that I was able to find it at a local art store, and it was already made into a thin strip. For the thickness of the strip, I went with 1/8 of an inch, which was about 3.2 millimeters. The first thing that I had to do was cut it using a knife, and I made some small squares that were about 2 centimeters by 2 centimeters. This size was kind of arbitrary, but I figured it was best to start small and then scale it up. Now, on a quick side note, a lot of papers, including the one that went viral, made the pieces a lot thinner, and they were usually at most 1 millimeter. I felt that that was way too thin though, and at that point, it was getting closer to being paper than wood. Also, the last time that I did this, the pieces kind of fell apart, and I was worried that it was because I'd made them too thin. But anyway, when I was done cutting them, I dropped them onto a dish, and I put them in an oven to dry. The paper said to keep it at 105°C for 24 hours to get rid of any moisture in the wood. I think they were already pretty dry though, and when I pulled them out the next day, they looked exactly the same. Now, what I had to do next was chemically treat the wood and remove something called lignin, and I also had to bleach them white. In my last attempt, I pulled out the lignin using a boiling solution of sodium sulfite and sodium hydroxide, and then I bleached it using 30% hydrogen peroxide. That method seemed to work okay, but I didn't find that it was very efficient doing it in 2 steps. The method that I wanted to try, though, used sodium chlorite, which was able to do both at the same time. Also, in general, it's a lot easier to buy sodium chlorite than it is concentrated hydrogen peroxide. At least here in Canada, anything above 30% peroxide is controlled because it can be used to make explosives, and if you do manage to buy it, you can sometimes end up on a list. This is very different than the sodium chlorite, which has little to no regulation, and you can just buy it online. The reason that it's so available, though, is kind of unfortunate. It has a legitimate use as a disinfectant or cleaner, but more often than not, it's sold as some sort of alternative medicine. People use it to make something called Miracle Mineral Supplement, or MMS for short, and they claim that it can cure everything from cancer to autism. The only problem, though, is that at least chemically, it's kind of similar to drinking dilute bleach. There's no real evidence that it does anything besides destroy your insides. So now, just like that other time when I bought cyanide almonds, I was a bit conflicted because I didn't want to support a market like this. However, it was on Amazon, and it was by far the cheapest and easiest way to get it, so when it eventually arrived, I was able to put together my wood treating solution. According to the paper, I had to make a 1 weight percent sodium chlorite with acetate buffer solution with a pH of 4.6 at 80°C. At first glance, this kind of seemed like a complicated and maybe hard thing to do, but it was actually relatively simple. To put it together, I started by adding 125 mils of water, followed by 1.67 grams of sodium acetate and 1.15 mils of acetic acid. I then turned on the stirring, and when all this had dissolved, I was already almost done. I only had one more ingredient to add, which was 1.3 grams of the sodium chlorite. When all of this had also dissolved, I added a thermometer, turned on the heating, and waited for it to get to about 80 C. As it warmed up, the acetic acid was slowly reacting with the sodium chlorite and releasing chlorous acid, which quickly broke down into chlorine dioxide. When it eventually got to 80 C, I turned off the stirring and I dropped in the pieces of wood. I did my best to spread them out, but unfortunately, there just wasn't enough space. So, I poured everything into a bigger beaker. As it sat there, the chlorine dioxide solution was attacking and dissolving one of the major components of the wood, called lignin. In general, wood is around 25% lignin, which is kind of like a glue that holds the wood fibers together. By taking it away, I was making the wood more porous, and I was opening up the space between the wood fibers. I was also getting rid of the natural yellow color that wood has, which mostly comes from the lignin. According to the paper, this process should bring the lignin content down from the 25% that I mentioned before to only about 3%. What I was supposed to be left with was mostly cellulose and hemicellulose, which were naturally colorless. About 7 hours later, they eventually looked almost completely white, and I felt that it was done. So I pulled them all out, and I dropped them into some distilled water. I then left them overnight for all the chemicals to slowly diffuse out. The next day, I filled another bowl with 100% ethanol, and I transferred them all over. I waited another day, and then I did the exact same thing with a 50-50 mixture of ethanol and acetone, and then with pure acetone. As far as I know, the paper doesn't really go into detail as to why all these solvent washings have to be done, but I think the major reason is to just get rid of the water. After a few days of mostly waiting, I was eventually left with some little dry pieces of wood, which were hopefully close to lignin-free. They clearly still weren't transparent though, and that was because I still had one major step to do, which was infuse them with plastic. However, before doing that, I took a closer look at one of them. The first thing that I tried was bending it a bit to see how strong it was. The last time I did this, the pieces all became super soft and bendy, and I was kind of expecting the same thing to happen. However, they were actually still pretty tough, and they felt similar to before the treatment. I'm not exactly sure whether this was because I used balsa this time, or if it was because of the different process. My opinion, though, is that it was probably a combination of the two. Either way, it was a pleasant surprise, and it meant that it was probably possible to safely make pieces that were both thinner and larger. Something else that I noticed was that even though they weren't exactly transparent, they were definitely more transparent than regular wood. It was still way too hazy to see any details through it, but it was vaguely possible to see something. But anyway, it was now time to try and, hopefully, make it completely see-through. To do this, as I mentioned before, I had to infuse the wood with some sort of plastic, and the last time that I did this, I used an epoxy resin. There were at least a few things, though, that I didn't like about the epoxy. The first was that it was a two-part mixture, and the moment the two parts were mixed together, they would start to react. This gave me a limited time to work on it before it started to harden, and I found that this made things really rushed, and it was hard to do a good job. The second, and probably more important reason, is that epoxy has a tendency to turn yellow. This is often because of exposure to UV light, but I kept mine in a cupboard, and it still somehow happened. What I did find interesting, though, was that a lot of papers on transparent wood used epoxy, including the one that recently went viral. In fact, they often use the exact same stuff that I used. In my opinion, though, this was a major problem, especially considering that transparent wood is supposed to be a potential replacement for glass windows. Windows are constantly exposed to the UV and sunlight, and if epoxy were used, you'd probably end up with a nasty yellow window. This was one major thing that I liked about the paper that I decided to follow. They didn't go with epoxy, and they instead went with something called methyl methacrylate, or MMA for short. When this polymerized, it would make acrylic, also known as plexiglass, and it didn't have the same yellowing issue. Its polymerization was also triggered by heating it, and this meant that I could actually choose when I wanted it to harden. This all sounded pretty good to me, so I ordered some methyl methacrylate as well as an initiator called AIBN. Unfortunately, I couldn't just add them both directly to the wood, and I first had to partially polymerize the MMA. To do this, I started by adding a very small amount of the initiator. After that, I poured in about 50 mils of the methyl methacrylate, and I dropped in a stir bar. I then turned on the stirring, and when everything had dissolved, I moved the flask to a hot water bath. When the temperature got above about 40 C, the initiator was supposed to start breaking down and releasing free radicals. These free radicals would then attack a molecule of MMA, which would turn it into a more reactive form, which could attack another molecule of MMA. This process, known as polymerization, would then keep going, and it would slowly grow chains of methacrylate molecules. The length that these chains grew to was mostly determined by temperature and time, and the paper said to react it for 15 minutes at 75 C. So, after 15 minutes, I pulled it out, and I dropped it into some ice water. This quickly dropped the temperature, and it was supposed to stop the polymerization at whatever level it was at. I let it sit there for about 10 minutes, and I was now ready to add it to the wood. To do this, I got out my vacuum chamber, and I added some of the pre-polymerized MMA to a small dish. I then dropped in one of the pieces, and I made sure that it was completely submerged. I also covered it with another dish, because this step can sometimes splash a lot, and I closed the chamber. After that, I turned on my vacuum pump, and it started to bubble because air was getting pulled out of the wood. Then, as I pulled a stronger vacuum, it started boiling off the acetone, as well as some of the unpolymerized MMA. Over the next 15 minutes, the bubbling gradually slowed down, and eventually became more or less constant. I kept it going for another 15 minutes, and then I released the vacuum. This should have caused the MMA to start rushing into the wood and filling all the spaces that the air and acetone used to occupy. I really thought that at this step it would have started looking transparent, but it looked almost exactly the same. This didn't concern me too much though, and I thought that maybe it only cleared up when the MMA was fully polymerized. I then did 2 more vacuum cycles of 15 minutes, and at this point, the wood should have been completely filled with the MMA. Now, what I had to do next, according to the paper, was sandwich it between 2 pieces of glass. So what I did was drop it onto a glass square that I found on Amazon, and this part was actually the main reason why I chose to do this method. It was the only one that seemed to wedge it between glass, and their final pieces were nice and flat. When I looked closely at almost every other paper that I found, their samples were wavy or warped. But anyway, I then put another glass square on top of it, and I wrapped it all up with aluminum foil. I wasn't exactly sure what the aluminum foil was for, but the paper said to use it, so I just did what it said. With it all nicely packaged, I put it in my oven that I had preheated to 70 C, and I left it in there for 4 hours. As it sat there, the methacrylate was supposed to start polymerizing again, and when all of it had eventually reacted, I should have been left with solid acrylic. When I came back and took it out of the oven, I was hoping to see a super nice and beautiful piece of transparent wood. But that, of course, wasn't what I saw. It's, it looks the exact same. Looks like I didn't do anything to it. Okay, so that was nothing short of a complete failure, and I was gonna have to try again. The MMA had all apparently just disappeared, but that was what the pre-polymerization was supposed to be preventing. By polymerizing it a bit and making some short chains, it should have been making it a lot harder for the MMA to vaporize, and so that it wouldn't just disappear in the oven. Something clearly went wrong though, and I thought that maybe it was the initiator. It was possible that it might be old or bad or something, so this time, I tried using twice the amount. Unlike last time, it started releasing some small gas bubbles, and this was all nitrogen. It was forming as the initiator was being degraded, and it was a good sign that it was actually working. The fact that I didn't see this happen last time probably meant that I'd barely done anything. Over the next 15 minutes, it also got thicker and thicker, which was another good sign, and it meant that it was actually polymerizing. Like before, I then pulled it out, and I dropped it into ice water. When it got to around room temperature, I added the thicker MMA to the dish. I then dropped in another piece of wood, added a bit more MMA, and started the same vacuum cycle. After turning on the vacuum though, I realized that I had gotten a bit too excited, and I had forgotten to add the cover dish. This wasn't a huge issue though, because besides that first pop, it wasn't actually splashing very much, and I just added it after the first cycle. Unlike last time, as I continued pulling a vacuum on it, the MMA slowly got thicker and thicker. I think this was because it was pulling off a lot of the unpolymerized methacrylate and concentrating the partially polymerized stuff. This evaporation was also causing it to cool down, which would thicken it even more. After the last vacuum cycle, the wood still wasn't completely clear, but it did look a bit more transparent. I then took it out, squished it between some new glass squares, and threw it in the oven. I was again hoping that it would just magically clear up and look amazing, but that wasn't the case. I mean, it was definitely better than before, but I wouldn't call it good. Also, a major problem that I was noticing was that it looked like the acrylic was stuck to the glass. As far as I know, this issue was never mentioned in the paper, and I kind of just assumed that as it cooled, that it would pop itself off. However, that clearly didn't happen. The good news is that it actually worked this time. Kind of. The bad news is, it sucks. Even at room temperature, it was completely stuck, and to get it off, I made some score lines in the glass. I then got out my hammer, and I carefully smashed it to pieces. I also did the exact same thing to the other side, and I was eventually able to free my piece. There was unfortunately still some glass stuck to it though, so again, I carefully hit it with the hammer. After that, I used a Dremel, and I cut off the extra bits of plastic. I also sanded it, just to clean it up a bit. The final piece was only kind of transparent, and it was a bit disappointing. What was good though was that it was completely flat, and it didn't look bent at all. When I tested it, I had to use a lot of backlight, but it was possible to see through it. It was still super hazy though, and a lot of it was still very yellow. This yellowness told me that I clearly hadn't treated the wood pieces for long enough, and there was still too much lignin in there. I think the biggest problem, though, was that I'd made the pieces way too thick. I did this because I was really worried that they were going to fall apart, but they turned out to be totally fine. So, this extra thickness wasn't really doing anything, and it was basically just making it hazier. It was making the whole thing a lot less transparent, even in the non-yellow parts that kind of looked okay. Based on this first, and kind of successful run, I had a bunch of issues to fix, and the first thing that I did was cut some thinner pieces. I was clearly a bit too ambitious trying to make them so thick, and they for sure had to be reduced, but I didn't want to go all the way down to 1 millimeter. I instead settled for 1.5 millimeters, and I found these thinner balsa strips on Amazon. I then did the exact same process as before, except this time, I made sure to keep going until they were completely white. This ended up taking about 7 hours, and when I felt they looked okay, I dropped them all into some water, and I compared them to the older pieces. The difference was pretty obvious, and what I had now was definitely a lot better. I then dried the pieces using solvents, but this time, because it was way cheaper, I used 99% isopropyl alcohol instead of the ethanol. This again took a few days, and when it was done, they were already kind of transparent. Now, for the pieces of glass, I stopped using those thin and flimsy ones. I instead found these coasters on Amazon, which were much thicker, and hopefully a lot stronger. I also decided to spray them with some mold release to prevent the acrylic from getting stuck to the glass. The only issue was that I had no idea how to properly apply it, and I ran into a bunch of problems. After a few small tests, though, I found something that seemed to work. Both of the plates were first cleaned with some alcohol, and then I lightly sprayed them with the mold release. After that, I used a brush to spread it out and to try to give it an even coating. I let it evaporate for about 10 minutes, and when it started beating up, I wiped it around to even it out. I then added a second layer by repeating the exact same thing, and when that was done, I polished it with a microfiber towel. This left me with a pretty shiny and clean surface, which the acrylic hopefully wouldn't get stuck to. With this all ready, I prepared some more methyl methacrylate, but even with twice the initiator, it didn't work in 15 minutes. It instead took 30 minutes to thicken, and I have no idea why. But either way, I now had everything that I needed, and I started treating one of the pieces. I did the exact same thing as before with 3 vacuum cycles, and when it was done, it was looking pretty good. I then carefully dropped it onto one of the new pieces of glass, sandwiched it with another one, wrapped it, and put it in the oven. With all the changes, I was extremely hopeful for this one, but it of course also kind of failed. The wood was definitely more transparent, but the glass had somehow tipped over. The combination of the stronger glass and the mold release seemed to work though, and I was able to easily pop off the top one.
It actually worked.
However, the actual piece of wood unfortunately didn't pop off as nicely. This made it even sadder than I had hoped.
Why?
But at least the problems were quite fixable. So, I decided to quickly try it again. This time, after dropping on the treated piece of wood, I added some spacers that I'd cut out of the untreated balsa. I figured it was an easy fix to stop the glass from tipping over, and I also used aluminum tape to hold it all in place. This felt a lot more solid than before, and it was way better than just trying to balance everything on a piece of wood in the middle. Also, because of the issue before with the piece of wood still getting stuck, I treated the glass with 4 layers of mold release instead of just 2. The result from this run, finally, wasn't a complete disaster. For a second though, I did think that the piece was stuck again, but that wasn't the case. The piece from this one was even better, however, it was still a bit problematic. The side that was touching the bottom plate was almost completely smooth and shiny, but the other side looked like it was missing acrylic in the middle. I wasn't sure why this happened, and I thought that maybe it was just because the surface of the wood wasn't perfectly flat. It was possible that the glass was only touching it in a few high spots, and there was a slight gap between the rest. To fix this, I thought that it might work to just put some weight on it and to really squish it together. So now, for the hopefully final attempt, I did it pretty much in the exact same way as the last one. I then put it in the oven, and for the weight, I needed something that was small, but really heavy. I initially had no idea what to use, and I probably spent 15 minutes just walking around the room looking for something. What I ended up finding turned out to be perfect though, and it was the 5-pound tungsten cube that I had randomly bought over a year ago. I then waited the usual 4 hours, and when I opened it up, I was pretty happy with what I saw. I let it sit for about 30 minutes to cool down, and then I took it apart. It was a bit stubborn, but it was pretty easy to crack it open with a screwdriver. Like before, I got rid of the extra plastic using a Dremel, and I also sanded it a bit. This one was by far the best result, and I felt that it looked pretty good. The top side was still a bit rough, but the bottom was close to perfect. So the extra weight apparently didn't do very much for the top, but it seemed to help the bottom. Now, when I tested it, it was way more transparent, and I could easily read the text through it. My only issue with this piece was the rougher top, and I started thinking that maybe the top just had problems. However, I thought that the fix was relatively easy. I figured that all I had to do was just selectively treat the top rough side by painting some more methacrylate on it. I would then do the exact same vacuum cycle, and I would squish this treated side against the bottom glass. In my mind, this made total sense, and I was almost certain that it would work. So I did the really smart thing, and I completely skipped trying it. I instead just assumed it would work, and I jumped right into scaling things up. I honestly thought that it was just going to be really straightforward and easy, because I assumed it was just what I had done before, but bigger. However, that turned out to be a terrible assumption. I quickly learned that the larger scale had a whole bunch of its own issues that never even occurred to me. For example, any gas bubbles that formed now had a much harder time escaping, especially if they formed near the middle of the piece. This gave me a couple attempts where there were clearly some bubbles that got trapped. I also had one run where the piece cracked as it was cooling down, and another one where the methacrylate drifted away from it while it was in the oven. There was also my favorite one, which absolutely refused to separate from the glass, and I had to help it a bit. I think the saddest part, though, was when I found out that it wasn't going to work to selectively treat one side. I mean, it did technically work, and I was able to get 2 sides that were smooth, but it also introduced a bunch of weird cracks. I did think it was kind of interesting, though, and it had a cool effect when I turned the piece 90 degrees. But with all that being said, the main point here is that scaling it up turned out to be a lot trickier than I thought. On the surface, the process appeared really simple, but every small detail seemed to matter. Eventually, though, after a week of what felt like constant failures, I came up with a process that I felt would work. To try it out, I cooked up what I was hoping would be my last piece, and I soaked it in the same solvents. When that was eventually ready, I started making the pre-polymerized methacrylate, and this time, I used a lot less initiator. Instead of twice the amount, I now only used 20% more. Also, in general, I found that this was actually one of the hardest parts. This was because I found that there was an optimal thickness or viscosity that I had to bring it to, but it never seemed to take the same amount of time. Sometimes it was ready after as little as 15 minutes, and other times it took closer to 40. It's very possible that I was just doing something wrong, but either way, I ended up having to use a method that wasn't exactly super scientific. I basically just got good at shaking it around and looking at it, and knowing when it was ready. When it eventually got to what I felt was the right thickness, I pulled it out, and I dropped it into ice water. When it had cooled down to around room temperature, I poured it all into a large dish. I then dropped in the piece of wood, and I made sure that it was completely submerged. Now, I again had to do the 3 vacuum cycles on it, but this time I had to do them for much longer, at around 45 minutes each. I also pulled the strongest vacuum that I possibly could to try to get rid of all the acetone, as well as any unpolymerized methacrylate. I found that this was important because otherwise they would boil off as they sat in the oven and potentially introduce bubbles. There was a side effect to the extended vacuum though, and it caused the methacrylate to thicken a lot more. This made it very important to start with methacrylate that wasn't too thick, otherwise it would sometimes start to solidify before the end of the 3rd cycle. When it was done, I pulled it out, and I dropped it on a much larger glass plate. This plate was originally meant for 3D printers, and I had already treated it 4 times with mold release. I also made sure to completely polish the entire thing. Any unpolished parts could cause the acrylic to stick, and this was why one of my pieces ended up cracking. It could also cause it to not separate at all, and I really didn't want to have to smash any more glass. In most of the other runs, I used small wood spacers to help stabilize the glass plates, but I realized that they were actually sabotaging me almost the entire time. I think it took me way too long to find this out, but apparently methyl methacrylate contracts as it polymerizes, and it can lose up to 21% of its original volume. This meant that my piece was potentially shrinking quite a bit as it cured, and with the wood spacers in place, it was pulling itself away from the upper glass plate. This made it so that all the weight that I had added was basically doing nothing, and I had to stop using them. When I first realized this, I thought it was going to be a problem, and that I'd have to come up with some other way to balance the plates. However, it turned out that on this larger scale, they weren't even needed. The piece of wood was now big enough that there wasn't really an issue balancing the glass plate on it, and as long as I kept it more or less centered, it was totally fine. At this point, things were looking pretty good, and I put it in my oven. I then loaded it up with a much larger tungsten cube, which was coincidentally the perfect size, and it weighed about 40 pounds. I had bought this one around the same time as the smaller one, and I had originally planned to use it for a video. I never really ended up getting around to doing that. However, I like to think that this technically counts. With everything in place, I made sure that everything was all level so that the methacrylate wouldn't drift. Then, when I felt that it looked good, I closed the oven and I turned it on. In a lot of the other runs, I had preheated the oven, but I found that it worked better when it heated up slowly from room temperature. Now, it was just a matter of waiting, and I was pretty anxious to see the result. When I came back to it 4 hours later, I pulled it out of the oven, and I was kind of happy with what I saw. I then waited for it to cool down and slowly separate from the glass. This part can sometimes be surprisingly loud, and it sometimes really sounded like something was breaking. There was also one time where the acrylic actually did snap, so I couldn't help but be a bit nervous. When I came back to it about 30 minutes later, it thankfully wasn't broken, and I cut all the pieces of tape. To open it up, I pulled on the top plate, and it came off pretty easily. I was a bit worried that the piece itself would be hard to remove, but it also came off without much effort. Now, looking closer at what I had made, and it was kind of bad and good at the same time. The part that was touching the bottom plate was almost perfect, but the top wasn't nearly as beautiful. I mean, it was still by far the best result that I had ever gotten, especially when you compare it to what I was getting before. Even without the spacers though, the top part still wasn't turning out as well as I had hoped, and I think that was just because of gravity. As it sat in the oven, the methacrylate was slowly sinking down and away from the top plate, and there wasn't much I could do to stop that. Thankfully though, I felt the fix was relatively easy, and I just had to treat it a second time. To do this, I first had to clean it up a bit by cutting off all the extra plastic. I then lightly sanded both sides, and when I felt that it was good, I dropped it into some freshly prepared methacrylate. I then did the typical 3 vacuum cycles on it, but this time, they were much shorter. This was because there wasn't any acetone to get rid of, and I only did them for about 10 minutes. When it was done, there was unfortunately a small part in the bottom corner that refused to fill with resin. However, I was kind of hoping that it would just magically disappear in the oven. I then dropped the piece onto the glass plate, and I made sure to flip it so that the side I wanted to fix was against the bottom plate. I did this because the bottom side always seemed to turn out nicer, and I thought this might help. After that, I added the upper plate, and I taped it all together. I then loaded it up with the cube again, made sure that it was level, and turned on the oven. I was again really anxious to see how it turned out, and I patiently waited the 4 hours. When it was done, I took away the cube, and I was almost immediately disappointed. To know exactly how bad it was, though, I first had to wait the 30 minutes for it to cool down. It didn't end up being as bad as I thought, but it also wasn't great, and to be honest, I kind of expected that. This process was just way too unpredictable, and the likelihood of having both sides come out perfect was extremely low. To a certain degree, I was hoping that luck would be on my side and a miracle would happen, but I really didn't expect it to. Up until now, my main goal was mostly just to fill the wood with acrylic and to get it to the point that it only had minor imperfections. This was almost exactly what I had now, and to make it nice, I figured I just had to use some sandpaper. I started wet sanding it with 600 grit paper, but it wasn't coarse enough, and I ended up going down to 320. I kept going until it looked like the surface was perfectly even, and then I slowly moved up to finer and finer sandpapers until I got to 2500. At this point, it was starting to look pretty good, and for some reason, I feel like it actually started looking more like a piece of wood. It was still a bit too hazy though, because the surface was still a bit rough. So what I had to do next was polish it, and based on what I saw online, this plastic polish by Novus seemed to work pretty well. The instructions were pretty simple, and it said to start with the number 3. I spent a few minutes polishing both sides, and when I felt that it looked good, I washed it all off, and I moved on to the number 2. This one said to keep going until the polish disappeared, and I again did it on both sides. I then wiped it down with a microfiber towel, and I finished it with a good rinsing. Now, with it all polished and clean, I cut off the extra plastic. After that, I sanded the edges to clean them up a bit, and this was the final result. It was honestly way better than I ever thought it would be, and I was really happy with how it turned out. It technically still isn't perfect, but I think that's kind of a good thing. I think all the slight imperfections on the surface actually make it look more like a piece of wood, and less just like a slightly hazy piece of plastic. Also, I think the sanding made the grain of the wood much more obvious, which I thought was really nice. Now, for a quick transparency test like I did before, and it was way better. The text below it was extremely easy to see, and I didn't even need a backlight. One thing that I did notice though, now that it was against the white paper, was that it did have a slight yellow tint to it. Despite this though, and all of its flaws, it was still better than I ever expected, and I guess my revisit was successful. I mean, it was one of the most finicky and frustrating projects I've ever worked on, but it turned out almost exactly how I wanted it to. It also ended up still looking like a piece of wood and not a chunk of plastic, which I was really happy about. In the future, I think I would like to try and scale things up even more, and it would be really cool to make a proper full-size window. However, for now, and at least for a while, I'm kind of done thinking about transparent wood. Now, on a bit more of a personal note, I mentioned in my last video that I was moving to a new space and building a new lab. And well, it's turned out to be way more work than I thought, and for those of you wondering where I've basically just been doing construction for the last few months. It is very close to being done though, which I'm very happy about. What I'm not as happy about is how much it has cost, and it's been way more expensive than I could have ever imagined. So now, more than ever, a big thanks goes out to all my supporters on Patreon and to KiwiCo for sponsoring this video. If you haven't already heard about KiwiCo, they make these really fun and engaging monthly crates that are designed to give kids a hands-on experience in science, technology, engineering, arts, and math. Let's do this. Every crate comes with detailed kid-friendly instructions, as well as all the supplies that you need to put it together, so you never need to make any runs to the store. The projects that they have are also extremely well thought out, and I'm actually really impressed with what they offer. For example, this one that I'm putting together is supposed to be a fully functional ukulele. However, I've never played a ukulele, so we'll see how functional it ends up being. Yeah, I got some practice to do. The main thing that KiwiCo offers is monthly crates, and they have 8 subscription lines for a variety of different ages. However, they also have a shop where you can just buy single projects, and I kind of want this experiment one. But with all that being said, if you're looking for a fun project for your kids, or even yourself, I recommend checking out KiwiCo. If you decide to try them out, you should also be sure to use my special link in the description, kiwico.com/NiallRed, to get 50% off your first month of any crate. That's it. As usual, a big thanks goes out to all my supporters on Patreon. Everyone who supports me can see all my new videos at least 24 hours before I post them to YouTube. You'll also get access to all the older videos that I had to take down, and if you support me with $5 or more, you'll get your name at the end like you see here.